equivalence class definition for x belongs to some integer z, define the equivalence class of x with respect to congruence modulo n by equivalence class of x equals, here you can call it this one as z suffix n also. So a is belongs to some integer z such that a is congruent to x mod n. Remember this here definition. So here how it is works. Example, first one, here I am taking z3 means mod 3. z3 means it is an mod 3. So z3, what are the equivalence classes? You will get equivalence classes andre here remainders ಯಾವ್ಯಾವುದು ಬರುತ್ತೆ ಅವೆಲ್ಲ equivalence classes ಆಗಿರುತ್ತೆ. So if you divide this one, so here you have 1 multiply with 0, so you will get 0. If you subtract, you will get 1. 3 in the divide ಮಾಡಿದ್ರೆ here multiply ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ remainder 1 ಬಂತು. So starting it is always with 0 and 1 is 1 equivalence class, and this is 1, and here 3 into 2 multiply with 0, you will get 0. If you subtract, you will get remainder is 2. So remainder 2 antu. So ಯಾವುದೇ number here, if you take any big numbers, these numbers will be repeated. ಈ numbers ಬರುತ್ತೆ, ಇನ್ಯಾವ numbers ಕೂಡ ಬರಲ್ಲ. Here for example, if I take 15, 3 5s are 15, remainder is 0. You got this one. Next 17 I will take. Here 3 5s are 15. So if you subtract, what you get? Remainder is 2. If you subtract, what is the remainder? Remainder will get 2. So if you take it 23, so now 3 in the divide ಮಾಡಿದ್ರೆ what do you get here? 3 7s are 21. Again remainder is 2. And here if you take 25 ತಗೊಂಡ್ರೆ 3 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? 3 8s are 24. So what do you get? Remainder is 1. Means only these numbers will be repeated in mod 3. So remember that one. So here this can be defined as, here equivalence class of 0 is defined as all those numbers which gives 0 as remainder when you divide an integer by n. So n means depends on mod. So here now you have to check for each one. So equivalent class of 0, 1 and 2. So when you get remainder is 0, you have to find out all the numbers. When you get the remainder is 1, you have to find out the numbers. When you get remainder is 2, which numbers you have to remainder is 2, you have to find out. ಯಾವ ನಂಬರ್ಗೆ 0 ರಿಮೈಂಡರ್ ಬರುತ್ತೆ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕೀಗ. ಸೊ a belongs to some integer z. I am using this definition such that here a is congruent to 0 mod 3. So ಯಾವ ನಂಬರ್ಸ್ಗೆ you will get 0 ಬರುತ್ತೆ, you have to check it in integers. ರಿಮೈಂಡರ್ 0 ಯಾವುದಕ್ಕೆ ಬರುತ್ತೆ ಚೆಕ್ ಮಾಡಬೇಕು. ಸೊ ಏನಾಗುತ್ತೆ, ಯಾವ ನಂಬರ್ ಬರುತ್ತೆ here for 0 what you get, it is 0 only, and here 3 into for 3 ones are 3, remainder will get 0. So 3 into, if you take it minus 3 what you get, so minus here 1, so you get plus 3, multiply with minus 1 you will get minus 3, subtract this one, so this become plus, so remainder will get 0. So that means plus or minus 3, and here next plus or minus 9, and next here what you get, next element, before that plus or minus 6 also you get 0, because here 3 6 3 2s are 6, remainder is 0. So if you go for minus 6 also, it is remainder will get 0, and here plus or minus 9, so on. Next here find for equivalent class of 1. So what you get, equivalent class of 1. So for which numbers remainder will get 1, now we have to check. So a belongs to some integer z such that a is congruent to 1 mod 3. So for which numbers you will get remainder is 1, we have to check. So it is 1 is always there. So next one is, if I take 4, here if I go for 1 and if I go for 2, what do you get here, 0, here multiply with 0, so you'll get, what is the difference, difference is remainder is will get 2. So what is the remainder will get 1, so this is not possible. So for 4 it is, you will get here, what do you get, if I divide 3 ones are 3, so remainder is 1, and here minus 2. So if I multiply with 1, so minus 1 you will get minus 3, if you subtract this becomes 4, so what do you get, you will get plus 1, so you will get minus 2, and here you will get for 7, and here you will get for minus 5, 10, so on. So here for 2, equivalence class of 2, so what you get, a is belongs to some integer z such that a is congruent to 2 mod 3, 2 mod 3. So when here remainder should be 2 you will get. So for which numbers you will get remainder is 2, you have to check. So for 2 it is always there, so here 2, so it 3 zeros, if you multiply with 0 you will get 0, so if you subtract you will get 2 only, so I am written here 2, and here for 5 you will get remainder is 2, and for 8 3 2s are 6, and you will get remainder is 2, and for 11, so on. Here in left hand side here you will get for minus 1, and for minus 4, and here you will get for minus 7, so on. Now here if you combine all the 3 ಎಲ್ಲನೂ ಸೇರಿಸಿದ್ರೆ you will get an integer. So here look at here z, you will get an integer. So 0 is there, 0 is there, okay, 0, and here plus 1 minus 1, so plus or minus 1, and here plus 2, and here you get minus 2, so plus or minus 2, and here plus or minus 3, here plus or minus 3, and next plus 4 minus 4, so plus or minus 4, and here plus 5, and here minus 5, plus or minus 5, and here plus or minus 6, so on. If you continue like this, so you'll get an integer. So for any modulo, so if you find out the class here, find out this one, what you get if you go they given mod 3, so class intro what you get 0 1 2, so for this one you'll get 10 always integers for any mod. Suppose if you take it for mod 5, that means n equals 5. So if you take it n equals 5, what are the here class here, equivalence class will get 0 1 2 3 4. So these are the remainders you will get. So for every class interval 0 1 2 3 4, you have to find out the remainders. So okay, now next here, next definition. Definition: if A congruent to B mod n, 0 is less than equal to B is less than n, then B is called the least residue of A mod n. Yeah, for example, here mod 5. For mod 5, what are the remainders? So remainders, what are the remainders? 0 1 2 3 4. These are the remainders, right? So this is called least residue. This is called an least residue. What are the remainders? You will get the numbers. That is called least residues. So another definition, that one, complete residue. So let n be a fixed positive integer from a set a1 a2 a3 so on up to ak of integers is a complete residue modulo n if first one, ai is not congruent to aj mod n for each I is not equal to j. So second one, for each for each integers n, there exists a unique ai. So that is n is congruent to ai mod n. So this is the definition. This one is, I will take it as m. Here not first one, x is congruent to y mod n and x is congruent to z mod n. So this implies that x is congruent to yz into mod m into n. You can write. So for example, x is equal to 2 into mod 3, and here x is equal to 4 into mod 5. So this implies that here x equals 4 to the 8 mod 15. You can write. So I'll take the problems. First one, show that 41 divides 2 to the power of 20 minus 1. So solution, we have 2 to the power of 20 equals, here 2 to the power of 20 can be written as 2 to the power of 5 into 4. 5 4s are 20, right? So this can be written as 2 to the power of 5 can be written as 32 whole to the power of 4 can be right. So now here what is 41? It divides means that is mod 41. So you have to find out the remainder here. So 2 to the power of 20 minus 1. So we have to find out the remainder for this one. So here what we'll do here, 32. So 32 can be written as here 32. So divided with 41. So what do you get here? 41 means 41 ones are 41. So if you subtract, so you'll get minus 41. So this becomes minus 9. So this can be written as minus 9 mod 41 whole to the power of 4. This 4 here. So this is 2 to the power of 5 into whole to the power of 4. So this can be written as here. This can be here 2 to the power of 20 equals, what do you get? 9 to the power of 4 into mod 41. So don't write for mod 41 whole to the power of 4. That will be wrong here. Only for this remainder it will be multiplying. So here 2 to the power of 20 equals, here this can be written as 9 square into 9 square. So here I am using this one here, yz into, like that. So into mod 41. So here 2 to the power of 20 equals So this b is 81 into 81 mod 41. So this can, if you find out for 1, so it is apply for this one also. So divide this one. So 41 2s are, what do you get here? 82. So 2 here, 4 2s are 8. So how much if you subtract? It will become minus 1. So what you get, this becomes minus 1 into minus 1 into mod 41 you will get. So 81 into mod 41, this can be reduced to minus 1. So again for this one it reduces to minus 1. So minus into minus, it becomes plus 1 into mod 41 you will get. So 2 to the power of 20. So I will take it this one to left hand side. So 2 to the power of 20 minus 1 equals 0 mod 41. So if you divide this one, so remainder will get 0. So therefore this gives 41 divides 2 to the power of 20 minus 1, 2 to the power of 20 minus 1, thus the remainder is 0. Remainder is 0. Next one, find the remainder when 5 to the power of 48 is divided by 24 So solution, we have 5 to the power of 48. So this can be written as 5 square whole to the power of 24. Here ಹೀಗೆ ಮಾಡಬೇಕು ಅಂತೇನಿಲ್ಲ, ನಿಮ್ಮ ಇಷ್ಟ. ಹಿಯರ್ 12 into 2 ಆರು ಮಾಡ್ಕೋಬೋದು. ಸೊ 12 2s are 24 you will get. So into 2, if you multiply into 2, you will get 48. Otherwise 5 to the power of 4 into 12 you will get 5 to the power of 4 into 12. So you can write this one also, no problem. So if you take it lowest number, it is very easy to calculate. So ಕಮ್ಮಿ ಪವರ್ಸ್ ತೊಗೊಂಡ್ರೆ, ಕಮ್ಮಿ ನಂಬರ್ಸ್ ಬಂದರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ಡಿವೈಡೆಡ್ ಬೈ 24. ಸೊ ದಟ್ ಮೀನ್ಸ್ 24ರಿಂದ ಡಿವೈಡ್ ಆಗಬೇಕು. ಸೊ 5 ಸ್ಕ್ವೇರ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ 25. So 24 ones are 24. So remainder is, what you get, 1. So this can be written as 25 whole to the power of 24. So 25 can be written as mod ಪ್ರಕಾರ ಬರಿಬೇಕು ಇದನ್ನು. So mod ಪ್ರಕಾರ ಬರೆಯೋಕೆ ಹೋದರೆ what you get here 1. Here what you get 5 square whole to the power of 48 equals congruent to 1 mod 24. So, sorry, here also you have to write the congruent. Here also you have to write the congruent. Now 1 mod 24 whole to the power of, what you get here, 24. 4 you will get. Now this becomes 1 to the power of 24 mod 24 you will get. So this is 5 to the power of 48 you will get. 5 to the power of 48 equals 1 to the power of congruence to 1 to the power of 24 means it is 1 mod 24 you will get. So what is the remainder? Remainder is 1. That therefore when 5 to the power of 48 is divided by 24, the remainder is 1. Next problem. Find the remainder when 2 to the power of 340 is divided by 341. So here these are very large numbers, so try to reduce the numbers here. So solution, we have 340 they given here, right? Power is 340, so this can be written as 5 into 68. So 5 into 68 is, you will get an 340. So here 341 can be written as what I get here, 11 into 31. So 11 into 31 is 341 you will get. Now here 2 to the power of, I will take 340 can be written as 2 to the power of 5 into you will get 68. So you will get an 340. So now here for what you get here, that means it is 32 can be write 32 into 68. So now I will take for here 3 divided by 341 they given, divided by 341 means mod 341. That means, so this can be written as mod 11 into 31. So you can write 11 into 31 you will get 341. So first I will find out for mod 11, then I will find out for mod 31, then I will multiply. So what you get here, 32 can be written as, I will go for first mod 11. So 32 is divided by 11 and 32. So what you get here, you get 11 3 is 33. If you subtract, you will get minus 1. So what you get here, minus 1 mod 11 whole to the power of 68 for 2 to the power of 340, this one. So 2 to the power of 340 is congruent to minus 1 whole to the power of 68 into mod 11. So 2 to the power of 340 is congruent to, here it is even power, so this becomes plus 1 mod 11. Now same thing for, we have to find out for 31, mod 31. So what you get here, 2 to the power of 340 can be written as 2 to the power of 5 in whole to the power of 68. 8. So this can be written as 32 whole to the power of 68. So you have to write in congruence. So 2 to the power of 340 equal congruent to here 31. I divide with 31. So 1s are 31. If you subtract, you will get plus 1. So 1 mod 31 you will get. So whole to the power of 68. So 2 to the power of 340 is congruent to 1 to the power of 68 into mod 31 you can write. So 2 to the power of 340 is congruent to 1 mod 31. So this implies that 2 to the power of 340 is congruent to, so I will multiply here equation 2 and equation 1 here. Only I will multiply here. This can be written as 1 into 1, 1 only, mod 11 into 31. So this implies that 2 to the power of 340 is congruent to 1 mod 341. So remainder is 1. Next problem. What is the remainder when 3 to the power of 12 plus 5 to the power of 12 is divided by 13? So solution, we have here they given 3 to the power of 12 plus 5 to the power of 12. So find out is separate for 3 to the power of 12 and 5 to the power of 12 remainder, then add both. So we'll get the required solution. So we have, I'll take 3 square is equal to 9. So 9 can be written as, here 3 square is congruent to here 9. If you divide with 13, so what do you get? 1s are 13. So if you subtract, so we'll get minus 4. So minus 4 mod 13 you can write. So I'll squaring on both sides. So 3 square whole square is congruent to minus 4 mod 13 whole square. So this can be written as 3 to the power of 4 is congruent to minus 4 whole square mod 13. So this congruent to 16 mod 13. So what do you get? Divide with 13. So 13 ones are 13. So what is the remainder? Remainder is 3. So 3 to the power of 4 is congruent to 3 mod 13. So here you want 3 to the power of 12. So cubic on both sides. So what do you get? 3 cube mod 13 you will get. So 3 to the power of 12 is congruent to 27 mod 13. So here 13. So if you divide here, what you get? 27 divided by 13 means 13 2s are 26. What is the remainder? Remainder is 1. So is 3 to the power of 12 is 1 mod 13. So called as equation 1. Now consider 5 square. 5 to the power of, directly you can calculate for 5 to the power of 4 also. So if you go for 5 to the power of 4 is congruent to go for 5 square. So 5 square is congruent here equals, what you get? 25. So 5 square is congruent to 13. Here if you divide 13 to the 26, you will get -1 mod 13 you can write, right? So I will here you want 5 to the power of 12, so I'll multiply. Here you'll get an 1, so if you add the powers you'll get same 1 only you'll get. So what you get, 5 raising the power of 6 here, so is congruent to -1 whole to the power of 6 mod 13. ಸೊ ಹಿಯರ್ ರಿಮೈಂಡರ್ -1 ಇರೋದ್ರಿಂದ ಪವರ್ನ ಎಷ್ಟೇ ಜಾಸ್ತಿ ಮಾಡಿದ್ರು +1 -1 ವಿಲ್ ಗೆಟ್, ದಟ್ಸ್ ಆಲ್. ಸೊ 5 to the power of 12 is congruent to 1 mod 13. So call it as equation 2. So add 1 plus 2, so what you get, 3 to the power of 12 plus 5 to the power of 12 is congruent to, here 1 into 1 mod 13 only. So here the required remainder is 1. The required remainder is 1. So take on the problem, homework problem. Find the remainder. Find the remainder when 3 to the power of 287 is divided by 23. And here next one, what is the remainder when 11 to the power of 35 is divided by 13. So take on the homework on this.